Question 8, part 1. The diagram shows the curve y equals 2x plus 4 over x squared plus 5. Find dy dx and hence find the coordinates of the two stationary points. Well, looking at the graph, we've got a stationary point here and here. So when we get our answers, one of them should be negative and one of them should be smaller but positive. Okay, smaller I mean close to 0. So we don't need the curve in order to do that, but it's good to be aware of what our answers should look like so we know then if we've made a mistake. So let's get rid of the curve. So in order to differentiate this function, we're going to use the quotient rule, and we're going to say u equals 2x plus 4 and v equals x squared plus 5. So du dx equals 2, dv dx is 2x. So the quotient rule, which is no longer in the formula book, so you have to remember it, says that dy dx equals v du dx minus u dv dx. Because this is minus, you need to be careful you get those the right way around. And that's all divided by v squared. The way I like to remember this, when I was young, computer monitors were called visual display units, or VDU for short. So I just remember that TV comes first, and then like TV is in a television, and then I remember it's VDU that comes first. You can remember it however you want though. So all I've got to do now is substitute these numbers into this formula. So VDU, that's going to be this multiplied by this, so 2 lots of x squared plus 5 minus u dv, so this times this, all divided by v squared, so x squared plus 5 squared. Differentiating done. However, we're looking to find stationary points, so we are interested at a stationary point. We know that 2x squared plus 5 is 2x plus 4 over x squared plus 5 squared equals 0. Now, for any fraction to equal 0, it's got to be the top part that equals 0. Because if the bottom part equals 0 in a fraction, it's undefined. You can't divide by 0. So, for the purposes of solving this and finding out where it equals 0, I can ignore the bottom bit and say 2x squared plus 5 minus 2x brackets 2x plus 4 equals 0. The only condition of being allowed to do that is that when I get my solutions for x, I check that they don't make this bottom part 0, because if the bottom of your fraction is 0, then you have a bit of a problem. So let's expand this bracket out, and this one too. Oh, sorry, that's going to be 4. Okay, we're going to get a quadratic to solve it. I'm going to take everything over to the other side, because if I do 2x squared minus 4x squared, I'll get negative x squared, well, negative 2x squared over here, and I prefer that bit to be positive, so I'm moving everything over to there if you get confused with what I write next. So I get 2x squared, it's going to change the sign of everything, plus 8x minus 10, so I've cancelled these two into that. So I've now just got to solve this quadratic. I'm going to use a slightly different version of the AC method, which you might not have seen. If you've not seen this before, it's a really good method. Mr. Hegarty's got a great video on it at hegartymaths.com, so head over there and watch it. You'll be glad that you did. I'm looking for two numbers that multiply together to make 20, because a multiplied by c in this quadratic is minus 20. I also want two numbers which add together to make 8, which is b, and the numbers that are going to allow me to do that are plus 10 and minus 2. So I'm going to put a bracket here, 2x plus 10 and 2x minus 2. Don't include this in your working out, because technically if you expand that you don't get that, so what you've written isn't technically consistent. But I can use it as a tool, because if I cancel out any common factors on here, I get x plus 5 and x minus 1, and if you expand that you do get that. So I've got x plus 5 and x minus 1 equals 0. So my stationary points are at x equals minus 5 and x equals 1. So there's one negative, one positive, like we expected from the graph, and this one is closer to 0 than this one, like the graph suggested as well. However, we've not answered the question yet. A lot of people make this mistake. We are interested in finding the coordinates of the stationary point, not just what x is. We've only found the x part of the coordinate. So, when x is minus 5, using the original equation, not the differentiated version, y equals 2 lots of minus 5 plus 4 over minus 5 squared plus 5. Pop that into your calculator, you get minus a fifth for y. So our coordinate is minus 5 minus a fifth. That's the first coordinate of the stationary point. The other stationary point, when x equals 1, y is going to equal 2 lots of 1 plus 4 over 1 squared plus 5, and that's going to give you 1. So the other coordinate of the stationary point is 1, 1. And there are our two stationary points. Question 8, part 2. The function g is defined for all real values of x by g of x equals the absolute value, the modulus, of 2x plus 4 over x squared plus 5. Part A asks us to sketch the curve y equals g of x and state the range of g. Right, here we've got the curve from the previous question, which is pretty much the same as the one above here, just without these modulus signs. So we've got to think, what effect does taking the absolute value of this function do? And quite simply, it makes any negative values positive, but of the same magnitude. So all of this bit of the curve, that's going to stay the same. But here, instead of going below 0, you're going to get a reflection of this part just here like that. So you're going to get quite a sharp point here, and it's going to go away and come back towards the axis there like that. Oh, sorry, I've done that off the screen. I've done that on my graph. Just there. Okay, so I've just drawn on this bit here. Now I'm going to rub out this bit, so it's probably a good idea to do that in pencil. It's just a guideline to help you. If you want to, put a dotted line on there to show that you've reflected it. So this is y equals g of x. So we don't just have to sketch the curve, we have to state the range of g. Well, the range is any values it can take in the y direction. Now if we remember our answer from 8 part 1, we stated that the stationary points of the curve without the modulus sign were minus 5 minus a fifth and 1, 1. Well, this one is clearly not going to be negative anymore because we're taking the modulus of it. So this stationary point here, still minus 5 because it's still negative in the x direction, but this becomes a fifth. So exactly the same magnitude but the opposite sign. This helps us because we're interested in the range. So we know this point here, this turning point is at, well, this is at 1, 1. So the highest value this can take is 1. So the range is that y, or g of x, has to be between 0 and 1, inclusive, because it can be 0 and it can be 1. So 0 is less than or equal to y, it's less than or equal to 1. Part 2 is given that the equation g of x equals k, where k is a constant, has exactly two distinct real roots. Okay, so two real roots. Write down the set of possible values of k. So at the top of our graph, at the point y equals 1, there's only going to be one root. But everywhere just below 1, there'll be two roots. So our function must be strictly less than 1. Down here, if it's smaller than 1/5, we have 3 roots. Okay. If it's 1/5, we have 3 roots again. So it must be bigger than 1/5. It can't be 1/5 here. So our final answer for this, for the set of possible values of k, is between 1/5 and 1. You mustn't have greater than or equal to signs here. That's wrong. You'd lose marks for that.